Okay, in this video we're going to have a look at factorising some polynomials, so doing some examples. Okay, so in the last video we went through some of the theory, now it's time to put it into practice. Okay, so we're looking at factorising 6x squared takes 17x plus 7. Okay, so with some of these ones it can be a little bit tricky to actually work out what your factors are going to be, okay, because of this extra 6 in there. So what I like to do is have a look at some of your factors. So remember, we needed to be multiplying to 6 and multiplying to 7, and in the end we're going to be adding to our negative 17 there. Okay, so we need to have a think about this a little bit, okay, and what our factors are of 7, okay, because that's our nice easy one, because we know we've only got 1 and 7. Okay, with our factors of 6 though, we've got 6 and 1, and we've got 3 and 2. Okay, now the other thing that we can see here is we've got this negative in the middle, okay, and we've got a positive here. Okay, so if we only use positive numbers, okay, we're going to be in a bit of trouble here because we're not going to end up with our negative number in the middle. Okay, so what we're going to do is we're actually going to make both of our n1s here negative, okay, because we're going to multiply to there. Okay, so now we just need to start looking at our combinations of what we could do. So we could have, say, 6x take 1, and we could be our x take 7. We could be something like that. Okay, but when we look at this, we'll get our 6x times our x will give us our 6x squared, and our minus 1 and our minus 7 will give us 7. Okay, but we're going to have 6 times minus 7. Okay, well, clearly we're a fair bit off our 17 there, so we've got to always just jiggle around our numbers a little bit. Okay, given that 17 isn't a massive number, okay, we're probably going to be better off looking at our 3 and 2. Okay, so if we'll go ahead and look at our 3 and our 2. Okay, so when we look at this, we can go 3x by our 2x will indeed give us our 6x squared, and we've still got our 7 at the end. We're just trying to work out this middle, how we can get this 17. So we can go 3x times 7, negative 7, sorry, that'll give us our negative 21. But then we're going to be negative 1 times 2, so that's going to be take away 2. Well, we're still not quite there. That's going to give us negative 23. Okay, but we're in the ballpark. We're pretty close here, so it's probably not going to be too hard to finish figuring out this one. So if we might just switch these two around and see what happens. So we make our 2x take 1 and our 3x take 7. Okay, then we do our 2 times our 3 will give us our 6. Okay, we're still going to get our positive 7. But we go 2 times negative 7 will give us negative 14. Okay, and negative 1 times 3 will give us minus 3, which is indeed going to give us our minus 17 that we needed for our coefficient. Okay, so sometimes we just need a little bit of trial and error, but we can be a little bit cluey about it. Okay, when we have a look at our next one, okay, it's a fair bit harder because we can see here we only had one combination of factors that we need to worry about there, okay, being 1 and 7. Here, however, we've got a fair few more options. Okay, so for 12, we've got 12 and 1, we've got 6 and 2, we've got 3 and 4. Okay, fair few options there. Okay, and again for 20, okay, well, we're going to have 20 and 1, have 10 and 2, 4 and 5. Okay, so we've got a fair few options that we can look here. Okay, and we're trying to get to 31. Now everything's positive here, so we know that all our terms are going to be positive. We're not going to have any negatives like we had here. Okay, the 31, again, when we're dealing with 12 as a coefficient here and 20 as our constant at the end here, 31 is not really a very big number. Okay, so what I do straight away is rule out doing our 12 and our 20. Okay, because we can have our 1 and our 20 and our 12, it just doesn't really look like it's going to work out. Okay, so we probably look at some of our other options. Okay, so maybe we have a look at our 6 and 2 and our 10 and 2 and see what happens there. So we could look at going 6x, okay, say plus 10, because we know we're not going to want to times our 6 and our 10 together. That's going to be far too high. Okay, and 2x plus 2. Okay, so we'll see what happens when we do this. Okay, well, we get our 12x squared, that's what we wanted. Our 6x and our 2, that's going to give us 12x. Okay, we'll just worry about the 12. And 10 and 2 is going to give us 20. Okay, together we're at 32. Oh, so we're close, but we're not quite there. Okay, so we need to have a look at this again. Okay, so we could try switching these around. So that's our 2 and that's our 6. Okay, so now we can be still our 12 there. Now our 2x by our 2 is going to give us 4x, or we'll just put our 4. And this is going to give us our 10 and our 6 multiplying though. So that's way too high. So that hasn't worked. Okay, so we could stick with our 6 and our 2 and try our 4 and our 5. Okay, or we could stick with our 10 and our 2 and go to our 3 and our 4. Okay, but I do actually know, of course, what the answer is to this one. So we're going to jump straight down to our 3 and our 4. Okay, and we'll find, okay, that if we go with our 3x plus 4 times 4x plus 5, okay, that thing's going to work out for us here. Okay, so we've got 3x times 4x is going to give us our 12x. Okay, our 3x and our 5 is going to give us 15x, and our 4 and our 4x is going to give us 16x. Okay, which gives us our 31x that we need in the middle, and of course 4 times 5 is 20. Okay, so you can see with this one it could take me a bit longer to get there, which is fine, sometimes these will. Okay, of course, as we spoke about in our last video, we do have our general quadratic formula, which you'd almost go straight to with something with numbers as big as these. So the bigger your coefficients are here, okay, and our constant is there, okay, the more factor pairs we're likely to have. So when we've got lots of factor pairs, this can be a bit of an inefficient method. Okay, here we've only got one factor pair that we need to worry about, but when we get more it can stuff us up a little bit, and we're probably better off just moving on to something like our quadratic formula. Okay, now we'll flip over to our other examples that we've got here. Okay, so I've got a few more examples that we're going to have a look at. Okay, and they've all got something a little bit different about them. Okay, and that's why I like these examples. Okay, so our first one, example 3, we've got factorise 3y cubed take 81. Okay, now the first thing we're going to want to do here is do our 3 outside of our y cubed take 27. Okay, so 3 is a factor of 81. Okay, now what we can see here though is we've actually got one cube and another cube. Okay, because 27 is of course 3 cubed. Okay, so we've actually got the difference of 2 cubes here, so we can actually use that identity that we saw in our last video. So we can say then we're still going to have that 3 at the front. Okay, and we're going to have y take 3, okay, because this is our rule, okay, and then we're going to have y squared, okay, because it's always this one squared, okay, plus our y times our 3, so 3y, okay, plus our 3 squared, okay, because this is our rule for our difference between cubes, and we can neaten that up slightly, of course, and say that we've got our 9 at the end. Okay, so that's how we'd factorise that one. Okay, when we have a look at this one, I really like these type of examples. Okay, example 4, okay, because it's a common technique that we're going to use that come up on exams all the time. Okay, so we can see here we've got 2a to the 4 take 5a squared take 3 equals 0. So this is a really common thing that we'll need to do, is factorise this. Now you might look at that and go, well, we've got to the power of 4. Okay, so we're looking at a quartic, not a quadratic or anything. Okay, so how are we going to factorise this? Well, we can actually do a substitution. We can say let m, or any other letter you want, equal a squared. Okay, so we're going to replace a squared, okay, with the letter m. Now we can think, of course, of a to the 4 as a squared squared. Okay, this is the power of this one. 5a squared take 3 equals 0. So now, if we replace all the a squareds with m, we'll get 2m squared take 5m take 3 equals 0. Okay, so now we've got a quadratic that we're more familiar with looking at. Okay, and we can factorise this. Okay, so this can factorise, okay, So 2m plus 1, m take 3 equals 0. Okay, so you can see that's going to work. Now at this point, okay, we can actually put our a back in. So in say we've got our a squareds back in, sorry. So in say 2a squared plus 1 and a squared take 3, okay, equals 0. Okay. So what we can then do is go, okay, well, null factor law says that, sorry, our 2a squared plus 1, okay, equals 0. Okay, or that a squared take 3 equals 0. Okay, so we're going to run into a problem with this one though, as you'll see in a second. So we'll go 2a squared equals minus 1. So a squared equals minus a half. Well, hang on, we can't take the square root of a negative. Okay, so we're going to discount this. Okay, this part can't be equal to 0. Okay, which means this one must be. So we've got a squared equals 3. So a is going to equal plus or minus the square root of 3. And it's incredibly important not to forget the plus or minus. It's really easy. Students often just go, oh yep, square root, both sides. Okay, my answer is a equals the square root of 3. Okay, so you need to be careful there. Remember that it's plus or minus 3. Often there will be a context to this question, okay, which will often mean that you've got, say, discount the negative. Okay, we might be talking about length, for example, that we've just worked out doing this. Okay, well, length can't be a negative, so we know a would have to be positive root 3. Okay, we'll move on to work example 5 now, okay, which is factorise p cubed plus 2p squared take 4p take 8. Okay, I'm going to factorise this by grouping. Okay, now it'd be quite obvious to say, well, I've got p, p, p. Okay, well, I could do my 3 in 1 and go, here's one group because they've all got p's in it, and here's my other group. In fact, we don't want to do that. Okay, we actually want to do grouping of 2 and 2. Okay, and this one's quite a nice little example. Okay, so what we can do is look at our first group here, and obviously we've got a common factor of p squared, okay, which we're going to take out. So we've got p squared, okay, outside of p plus 2. Okay, so we're going to have a p left over here and our 2 left over. Okay, and here we can actually take out negative 4. So we're going to say take 4 outside of p plus 2. Okay, so I'll end up with p plus 2, which is, remember, when we group, that's what we want. Okay, we want something in the brackets that's the same, okay, which we've got here. So it'll give us p plus 2. Our brackets, what have we got left over? Well, we've got p squared take 4. Okay, and actually though, of course, this is actually the difference of 2 squares. So then say with them we've got p plus 2. Well, the difference of 2 squared means we do p plus 2 and p take 2. We've already got a p plus 2, so we can actually make that p plus 2 squared times p take 2. Okay, so it's quite a nice little worked example, that one there. Okay, because it uses a couple of different ideas. Okay, our last one is solving 3a squared take 4a plus 1 equals 0. Okay, so we're going to look at this and go, it's in the too hard basket. Okay, and we want to jump into our general quadratic formula. Okay, now you might be able to work through this without the general quadratic formula. Okay, but we just want to use it for this example. Okay, so remember our general quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, now you might not know that off the top of your head yet, okay, but you need to learn that and make sure you remember it. Okay, so b is our middle term here. Now don't forget, b is actually negative 4 in this case. Okay, so negative b is actually going to make it positive 4. So we have 4 plus or minus the square root, okay, of b squared. Well, negative 4 squared is 16. Take 4 times a, which is 3, times c, which is 1. Okay, over 2 times 3. Now, I actually broke my own rule here because we should have looked at the determinant first, which is just at this part here to make sure that it was positive. Okay, now we can see that we've got 16, take 4 times 3 times 1 is 12. Well, 16 take 12 is 4. So we are actually positive, so we will actually have answers. Remember, this part is our discriminant. Okay, if it's less than 0, we're not going to have a solution because we're going to be trying to take the square root of a negative, which we can't do, so we'll get no real solution. Okay, so we'll get 4 plus or minus the square root of, as I said, 16 take 12 is 4, over 2 times 3, okay, is 6. Now, at this stage, we really want to start talking our two solutions. So for here, we're going to have, now remember, it's quite easy to go, oh, well, x equals this. Well, actually, no. In this case, it was a's. So we're going to have a equals 4 plus, well, the square root of 4 is 2, okay, on 6, okay, or a equals 4 minus 2 on 6. Well, 4 plus 2 is 6, on 6 equals 1. 4 take 2 is 2 on 6, well 2 on 6 is 1 on 3. Okay, so hopefully you found this video tutorial worthwhile, okay, and hopefully you've got a few good examples that'll help you get through your classwork.